Hello, everyone. Thank you all for joining us for the 4th Canadian Underground Infrastructure Innovation Center Academy webinar. My name is Madison Carroll, and I'm the Program Manager for Dura-Line Academy and a member of CUIIC's Education Committee. I'm excited to be your moderator for today's session on microtechnology for utility fiber optics installation, presented by Kevin Jolly, Business Development Manager for Dura-Line. Organized by the Canadian Underground Infrastructure Innovation Center, the University of Alberta, and Benjamin Media Inc., CUIIC helps further underground infrastructure educational opportunities across Canada. CUIIC webinars cover a variety of pressing topics related to the sector and are presented by industry-leading professionals. Additionally, CUIIC hosts an annual innovation forum that showcases cutting-edge solutions and major trends in underground infrastructure. Scan the QR code shown here for more information about this upcoming event on May 25th. Additionally, CUIIC has many upcoming events and webinars shown on the slide here. For more information, visit academy.cuiic.ca. We also want to thank MPipe for sponsoring the 2023 CUIIC Academy Webinar Series. And now it is my pleasure to introduce my amazing colleague and today's speaker, Kevin Jolly. Kevin Jolly is a Business Development Manager for Dura-Line based out of Ontario, Canada. He is a registered communications distribution designer, has 19 years of experience in conduit pathway systems, and over 30 years of experience in the industry, which for those of you on who know Kevin, it's really hard to believe because he doesn't even look a day over 30. His extensive technical background and experience make him an expert on microtechnology, and his personality will bring today's session to life. I'm honored to turn the mic over to Kevin.
Thanks, Madison. Appreciate it. So today we're going to talk to you about other ways of deploying fiber in utility spaces. So we're talking about microtechnology. Before I jump into it, I'd like to say welcome and thank you very much for your time. There's a lot of material here in a short amount of time, so please feel free to enter your questions in the chat box down below, and then we can go through them in a Q&A session afterwards. And if we run out of time in Q&A, we can answer those questions directly offline through email or phone calls. So traditional fiber cables have been direct buried or pulled into traditional size conduits for years and years and years. The micro solution has just come around in Canada in the past 10 years. Really, this solution has been around for over 30 years. It was developed by British Telecom in the UK, and it is really nothing new, but in some applications, it's new to specific industries. The micro solution has changed that method of installing fiber, which saves time and cost and then speed of deployment, especially for any future additions. So we're moving towards a more connected world. And in that world, there's all kinds of different pieces of infrastructure that gets connected. So the Internet of Things keeps growing and growing, and I'm sure that you're all aware of this trend. The increased demand for bandwidth is not only in our fiber to the home, but more importantly in all aspects of our utility and service and life. This growth has been unprecedented and unpredictable. The Internet of Things is not only in our home, but other aspects like self-driving cars, smart highways, traffic monitoring, building automation, power systems, utility billings, leak detections, asset management. It just goes on and on. Even our wireless networks are requiring more and more cables to feed more antennas that are feeding our need for our need for more bandwidth. So why do we want to take a look at different fiber technologies? There we go. We want to take a look at the micro solution because it lowers the cost of construction and restorations, upgrades, maintenance costs, and it allows for a more flexible and scalable fiber deployment. How do we keep up with all this demand? We only can keep up with this with more bandwidth. We keep up with it by installing fiber at a faster and more economical rate. Some of the customers that are using Microtechnology in Canada, you'll recognize some of the names here. Here's just a short few of them. There's a vast amount of Canadian companies that have deployed fiber using Microtechnology into their networks. Some of them are large, some of them are small companies. And they're in a variety of markets. There's telco, there's commercial space, education, oil and gas, power, utility, and other water utilities. And the environments are in rural environments, remote environments, and also dense urban environments. So what is the Microtechnology solution? It consists of MicroDucts and future pathways with new microfiber cables that are smaller, lighter, and then smaller enclosures, hardware, and installations. We're going to talk about all of these things, but first we'll start with, oops, I'm behind a slide, sorry about that. But first we'll start with the MicroDuct. So what is MicroDuct? MicroDuct is made of high-density polyethylene. It's a tough, flexible product. There we go. It's lightweight, it's robust, and this material provides the protection for the fiber cables. MicroDuct comes in a various amount of sizes, and we talk about the size of MicroDuct by the outside diameter and the inside diameter. So the one you see in front of you now is we call 12-7-10, and that's 12.7 millimeters on the outside and 10 millimeters on the inside. The next one here, just have it, there we go, 14-10. It's 14 millimeters on the outside and 10 millimeters on the outside, on the inside. This gives you a thicker product that can yield a little bit more strength and more suitable for direct bury underground applications. You size the MicroDuct based on the fiber count of choice. This one here, the 1410, can hold 144 strands of microfiber. You size that based on a fill ratio, and the fill ratio is calculated by the cable outside diameter and the MicroDuct inside diameter. Just simple math, we're not looking at cross-sectional area here. In order to get your optimum jetting performance in the furthest distances, try to keep that fill ratio into 50 to 65% with an absolute maximum fill of 75%. And the thicker the MicroDuct, the more rugged it is for outside plant applications. There we go. Then you can bundle these MicroDucts together in order to form a FuturePath. This can give you multiple pathways for future need. They can go from single microducts to 24 ducts in various different configuration, including hybrids, where you can mix different sizes under one oversheath. We've got some with the 1410 on the outside, and this one here is 1612 on the inside. Or we can take a look at traditional sizes in a mix of Microtechnology and traditional sizes. So if your company is looking at changing your fiber plant, but you have a lot of existing fiber that is traditional, there's an offering that you can mix the two of them together. So the MicroDucts will provide additional space for future fiber and future additions and give you the ability to branch out along the path. Taking a look at capacity in a traditional method versus a Microtechnology method. If we take a look at a comparison between a 2-inch space, so a simple 2-inch conduit, the labor to install this 2-inch conduit is very, very similar to install a small FuturePath that would be about the same outside diameter. But the difference is how much capacity and how many fiber strands that little 2-inch space can handle. So on the left-hand side there, I hope it's your left, is a traditional 2-inch. And this method provides a simple pathway from point A to point B, where the installation of 1 or 2 cables, you can pull them in using a rope, rod, a bowline pull tape. You typically pull them as much fiber strands as that conduit can hold in day one, because it's very risky to add more cables over top of a live fiber optic cable. The risk of taking down a live network is sometimes too great, so you'll need to put it into a separate conduit. Second from the left would be a traditional 2-inch conduit populated with MicroDucts over top of an existing cable. So you can then jet in more cables into the existing MicroDucts at a future date. The two options on the other side are bundled FuturePath products offering multiple pathways to place fiber today and then into the future. You only require to install the fiber that you need today, leaving empty future pathways for future capacity when the requirement arises. Density and future-proofing is drastically different between these two products. Oh, sorry about that. I missed the slide. So you can see there the 2-inch on the ones on the left, and then the 2-inch with the MicroDucts, and then you've got your FuturePath products on the right-hand side. But if you notice the capacity difference, a 2-inch can typically hold about 576 strands of fiber versus into the 3,000 strands. Are you guys seeing the? I just got a message here that you may not be seeing the slides. Just making sure. Yep. Rick's saying he can't see the slides. Madison, maybe you can look into that one.
Yeah, Megan, I'm going to pull you in on that too.
So I'll continue to chat while we're there. Now we can see the slides, says Tim. Thanks, Tim. So the traditional method versus Microtechnology, and this is one of my favorite visuals. And here you have a truckload of 7 conduits. So the 1.25-inch conduit would hold roughly the same amount of fiber capacity as our 12.710 micro. And this is the same length of product. So 1.5 kilometers or roughly 5,000 feet on both. But you'll see it on the traditional method, you'll have a truckload of product versus 1 reel of the micro. Both of these will give you the same density, but you can imagine the cost and time savings for logistics, storage space, handling, safety, and the additional equipment that you would use for handling. Taking a look at some of the installation methodology between the two of them. On the top, just a visual comparison, quite large conduits taking up a lot of space in an open trench or directional drilling. And you can see the amount of guys that it's required to handle the traditional. Versus below, you've got 1 man operating a plow, a vibratory plow with a single reel of product. So you can imagine just the labor cost savings and labor savings of the two of them. So let's talk a little bit more about the fiber cable itself. Why microfiber? So it's 60% smaller, and we're seeing that the micro cables are becoming smaller and smaller in outside diameter as time goes. We're seeing the density of the microfiber reach and exceed the 864 strands. And then you can see the differences between the two ecologically. You've got smaller ducts, smaller components, smaller jacket. So that also alludes to less transportation. There's more kilometers of product per reel on a truck. You can handle it with smaller crews. It's a little bit safer. And your cable installation speeds are drastically faster. So when you take a look at the same fiber strand count, it's packaged in a much smaller package. The glass fiber itself, the core is exactly the same, but because the installation method has changed, the micro cables do not require the same vast tensile requirements as the traditional, and additional protection from the installation stresses of a traditional install. We'll talk a little bit more later on how it's installed and how you put it together. So on to handling. When you take a look at size and weight, when you take a look at the traditional cable, it's on a huge reel, and these two reels are the same footage, but there's a vast difference. So 60% less size and 70% less weight. So it's much easier to handle on a job site. When you're connecting those fibers together, you get hardware, boxes, enclosures, et cetera, and so forth. Because the micro cables are such small cables and the ducts are very small, the size of the enclosures can also be reduced. Those enclosures and pedestals can be drastically reduced and fewer of them required. So the quantity of volts in an installation goes down, and the size of the volts goes down, and the size of the enclosures required also gets reduced. You can deploy more homes and more fiber out of one vault than you can in a traditional method.
And Kevin, from Tim, we have a more of a comment, but that this would mean a much lesser impact on the environment through installation too, right?
Yeah, absolutely. It's less impact on the environment. And Tim, that's a great comment, because it's not only the material that goes into the fiber and the duct, there is less material that's going into there. There's less transportation. There's less, there's less equipment, less vaults. So the reason why you would have less vaults is because you can jet the cable a much further distance. In a traditional technology with traditional fiber, you can only pull that cable a short distance before you have to then pull it and pull it back into the next section. So with microtechnology, you can join the microducts together and jet further distances. I've personally jetted 2.5 kilometers in one shot, and we can talk a little bit more about that installation in the next section, which is a great lead into installation, placing equipment, and tools. So the equipment that you would use would be a cable jetter. And that cable jetter, there's a bunch of different manufacturers that make them. The jetter pushes the cable into the microduct and then introduces compressed air into the duct, which essentially floats the cable through the entire pathway. Versus in a traditional, you would connect on to the front of a traditional fiber with a bull line pull tape, and you would pull that product from one end, requiring that cable to have a very high tensile strength. So if you can imagine, you've got air that's swirling around the cable and picking up that cable and carrying the entire cable along that microduct, and that's essentially the technology and how it gets installed. So it gets installed at very high speeds. You're talking 300 to 500 feet a minute. And very easily on job sites, we've installed a kilometer of cable in approximately 18 minutes. There's various size of jetting equipment, and it all depends on the size of cable and the size of microduct that you would be installing it in. So accessories would be like couplers, end caps, and tools. There's very few specialty hand tools, but they're only there to help the success of the installation process. The couplers and end caps are airtight, watertight, and they can handle air pressures that exceed 230 psi. End caps will keep water, debris out of the ducts for future use, and they can even keep it from freezing. Thanks for advancing that slide. Keep it from freezing in the wintertime so that you can install fiber all year round. So the installation portion. To install the microducts themselves can be used a bunch of different traditional methods. You can open trench it, you can directional bore or directional drill, or plow them in. There's other methods like micro trenching, which we'll also talk about. So space is a factor in underground installation, especially when you get into urban environments, downtown corridors, rail systems. Space is a big factor. If we can reduce the space required for our fiber network, that's going to make it a lot easier to install in a utility corridor or into a very busy urban sidewalk or under roadways. We can place the boxes and the access points further apart because it's a lightweight cable that jets a much further distance. So you've got less boxes, and there's more space in those boxes to have a variety of different cables. The micro cable installs much faster, 300 to 500 feet per minute, versus a standard cable when you're rope rodding and pulling, 75 to a maximum 250 feet a minute if you're starting to use equipment. The equipment here on the micro is much smaller. It's easier to handle. It requires less labor and less people to handle the equipment. So one story was we were on a job site where we had a 2.5 kilometer jet, and it was an introductory to microtechnology for both an end user customer, it was a small telco, and a new contractor. So we did a demo day out on a job site, and we set up the equipment and a small reel of fiber. It was only 2.5 kilometers. And we set it up and we did the jetting in a very short period of time. The one comment that always stuck into my head was from the contractor that said, what you two guys did in a couple of hours would have taken his team 7 men for the better half of a week. So we're saving a massive amount of time. So time does not just equate to just labor cost. It also equates to how fast you can light up your network. So in a fiber to the home environment, you can get to your customers much, much faster, and you can light them up and start gaining that revenue back. So the revenue stream starts earlier. In an application like on your screen here, in a rail application, you're able to install a cable at high speeds so that you're not taking down your rail or taking down your manufacturing facility for a long period of time. When you take a look at direct bury installation methods, FuturePath is a tough product, or tougher than traditional product. So if you take a look at the difference between a standard traditional conduit, you're pulling that standard traditional conduit in by the end, versus a honeycomb effect in a micro solution. So it has a far superior tensile strength when you're directional drilling, plowing, or boring it in. Again, it can be plowed, bored, trenched, or pulled through existing conduits. A single reel can hold multiple pathways and provide much higher fiber density in a smaller space. There's also a way of, we call it microduct overrides, where you have an existing cable in an existing infrastructure. And what you do is you can install microducts over top of that existing cable multiple ways. You can either pull them in because the ducts are small and lightweight, or you can use the same jetting equipment to blow the microducts in from vault to vault in a traditional situation, connect them together with the microcouplers, and then jet in your microfiber from end to end in a high rate of speed. So there was an application of a cable TV company that was looking to install fiber through a residential network, a residential subdivision, in order to feed the network on the other side. So they were able to put microducts over top of their coax cable inside of their current existing plant, and then extend their fiber through a neighborhood without having to disturb the neighborhood at all. Just as a visualization here, you've got a couple of different options. We could put more pathways at a smaller size for fewer fiber counts, but more diverse to handle multiple different customers. Or you could put larger microducts in order to have higher fiber counts. It's all within the same duct size, and I keep using the same 2-inch, but that could be an inch size up to 3 or 4 inch sizes. When you're looking at microduct overrides, you kind of have to look at decision trees of what method can be used where. If your existing, thanks Madison, if your existing infrastructure is made of PVC, you can pull or rod it. If it's made of high density polyethylene, you can then pull, rod, or jet the microducts over top of the existing cables or just into an existing conduit. And then when you're looking at the inner diameters, you can, when you're installing a greater than 2-inch, you want to rope, rod, or pull. But if your conduit size, your existing conduit, is less than 2-inch in diameter, you can also use an air jet application. So you can then air assist or air jet in microducts over top of an existing cable, which will give your installation speed a lot faster and produce less risk on the existing cables. So we take a look at good, better, or best, different applications, your installation speed, mechanical pulling or insertion into an existing duct, rodding or mechanical insertion into that existing for less than 1,000 feet as better. And then the best is to be able to air jet the microducts inside the existing conduits, and that gives you longer distances and at high speed.
And Kevin, we have a good question coming in that just said that they want to confirm you can jet in microducts in an already occupied conduit, meaning a conduit that already has a cable installed. And this is for jetting or blowing, not pulling or pushing.
Yes. So the one example that I just briefly touched upon with a cable TV company is it had an existing cable installed in the conduit, and we were able to jet the microduct in the existing conduit over top of the existing cable. So you didn't have to rope or rod it. You didn't have to pull it in. You can actually blow in certain sizes, and there's certain limitations, but you can blow the microduct over top of an existing cable. And then you can connect all your microducts vault to vault throughout that network, and then jet in your micro cable inside the microduct through all of those vaults all in one shot. And that reduces the amount of splicing that would be required if you were doing it traditionally, or pulling it multiple times if you're doing it traditionally. When you're jetting a microduct over top of an existing cable, there's less risk in damaging that cable because there isn't really any of that pulling tension that you would use in a standard rod. Great question. Wanted to touch a little bit on microtrenching. Microtrenching is another option for installation, and it's where you're cutting like a narrow trench with a rotary blade into either concrete or asphalt. It could be sidewalks or parking lots, and then you insert a micro product into that micro trench vertically, and then that product can then snake through your network, and it's a very efficient installation process for specific applications. So you can complete 2,000 feet per day, and that's completed. So that's fully restored into that narrow micro trench. Here's some pictures of some of the saw cutting. So there's one on the side shoulder of the road, not directly in traffic. There's also saw cutting. The second from the left is in a downtown location where they're taking that expansion joint between the asphalt and the curb. And or a lot of people use right down the center yellow line of the road in the crown of the road. They use that micro trenching. We've got one application that was rather interesting. Downtown New York City is very congested underground. It's very difficult to get products underground because of the amount of utilities that are in that city corridor. And in this particular job, they used this FuturePath Flex product, which is a microduct that are attached together in a web. And you can see it on the left-hand side here. And then that web is inserted in your trench. So what we did was cut out the expansion joint between the sidewalk and the curb, and then install that vertical microduct FuturePath Flex into that space, and then fill it in with grout. And the beauty is that you now cut into a building from that trench and then transition off into specific buildings or drop off to specific customers. So in that particular application, it was great for a very congested environment. So there's certain applications where microtrenching is suitable, and there's other applications where you'd be better off to directional drill or plow if you can. Another application that we've come across is a mix of underground and aerial. And there's certain applications where it's required to transition from an underground to an aerial. So there's aerial products that are in Microtechnology for both lashable or self-support with an existing messenger. Everything needs to be UV rated when you're going outside, but this is a great solution where you need to transition to go across a waterway, a bridge, some sort of route that is very difficult. There's a great install that we did in Ontario that was a causeway, and we just couldn't get underground in that causeway, so we went aerially, and they were able to then have that transition from the underground to aerial and then back to underground. But when you install the fiber doesn't really know that it's running either underground or aerial. It transitions through that section without even knowing that it's gone to an aerial. Once that aerial portion is installed, you don't have to go back up into that aerial environment. Some of the problems with aerial would be the need for special training, working from heights, You've also got issues with squirrels and forest fires and ice loading, but there are certain applications where it can't really be helped. I'll get you there's your figure 8. So there's your self-supporting product. And then there's some installation shots. So if you can imagine, if you're going from underground to aerial and back to underground, if you can keep all your terminations underground, then you don't have to climb that pole again in the future. You can install more fiber at a later date by just jetting it from ground level.
And Kevin, we do have a question back on microtrenching. Do you have data on the performance of the reinstatement material for microtrenching? Here in the UK, it is hampering deployment.
Yes, there's a bunch of different reinstatement materials, and great question. Some work well in certain environments and others work well in other environments. Some of the problems that we have in Canada with microtrenching and that reinstatement material is frost cycles. So we get those freeze-thaw cycles over and over again throughout the month. And so the freeze-thaw cycles can heave and move that product underground. So it's very important to have those reinstatement grouts work for the environment that you're in. And again, another great segue, part of that would be in a training program. So some of those, I'll flip back into the training program. We've got lots of literature that can talk about those reinstatement materials in our training and our literature at Dura-Line. So back into microtechnology, sort of the technology can offer higher density fiber in a smaller area, lower installation cost, and future capacity of expansion. Often with a new technology, it requires some new training. So there's a Dura-Line Academy, which offers a training system. Right now, it's an online training system. And that's available thanks Madison, for any of those interested in advancing in microtechnology. So I'm going to pass it over to Madison, who's going to talk about the introductions to our Dura-Line Academy and how that can help you.
Thanks, Kevin. Yeah, we'll do this really quick, but we know this was a quick presentation and there's so much more that people want to know. So we do have the academy.duraline.com, and for everyone who's on this call, we do have a promo code for any of our full installation courses. So we have an installation fundamentals course that covers from an e-learning perspective a lot of the topics that Kevin touched on, as well as we actually have a microtrenching course. So David, to your question, feel free to jump in there. We have a trench course and an MDU full certification course, as well as a bunch of mini courses that expand upon these topics. So feel free to check that out. And we do have a CUIIC specific promo code so that anybody who wants to take those full certification courses can do so free of charge. Now, back to the end of the presentation before we end, what questions do people have? Feel free to pop them in the chat, or I'm not sure if you can actually unmute and ask it, but please feel free to send those in at this point.
And feel free, if you have any questions or thoughts in the future, feel free to get in touch with us. We'd be glad to help you out, answer questions, or assist you with projects that you're working on. If you're interested in transitioning from a traditional build over to a microtechnology, URL's incorrect on the slide.
Sorry, the M is actually, it got bounced down a line and I don't know how that happened. So it's academy.duraline.com. That's on us. But you can actually use the QR code that's now showing. That should take you right to the website.
Great. Thanks, Lori. Thanks for catching that. So yes, it's academy.duraline.com if you're interested in that academy. And once again, feel free to reach out anytime with any questions. If you need assistance, we've got teams of application engineers. We've got also different people that can help you out with design or ideas and concepts to help with whatever your application is. Let's look at another question.
Yes, so we do have another one that just came in. So what kind of delivery delays are you experiencing now?
So currently, our Microtechnology, our MicroDuct products are being shipped very, very quickly. So we're manufacturing these products out of Ontario. We are producing out of a new facility out of Edmonton. So we're increasing our capacity right across Canada. There are also 13 plants in the United States and a bunch of other plants globally. So if we are a little bit behind in our Canadian facilities, we can then rely on our other facilities to then deliver product on time. So you shouldn't see delays in material. You should see them in a timely manner.
Thanks, Kevin. And we have another one that just came in. Does the conduit resist swelling clay without major deformation?
I think you're asking like crush resistancy and whether when the clay swells, whether it's going to crush it. This is a very robust product. It's a very tough product, and it gets directional drilled in day in and day out. So yes, it does resist to a lot of those stresses.
Perfect. We've got a couple more. So this one actually pulls from an installation experience that someone had where they had a problem jetting 6mm outer diameter microfiber in a 1410 diameter microduct. He asked, should we have used a 9mm micro cable or would that matter? We were only able to jet a few hundred feet, which sucked.
Okay, so I'll talk a little bit about the cable jetting portion of it. The 6mm OD microfiber in a 1410 is absolutely the sweet spot. You should not have any problems with that. There are a lot of variables when it comes to jetting. So some of the variables, one of the major one is air pressure. So in traditional cables, they would also use air to pull a cable in with a parachute. And that was good to use about 90 PSI. When you're talking about microtechnology and microfiber, the pressure PSI needs to be up in the 200, 220 PSI. So if you were not using 220 PSI, I would say that's probably your first issue. There are other things to do in the amount of 90s and bends and stuff. It can handle a lot of bends. We have a test track in our Bracebridge facility in Ontario. And for every kilometer, there is 98 90-degree bends, and we're able to jet that kilometer with multiple different cables. So if you'd like, I think it was CUIIC that had that question. If you'd like some on-site assistance, we've got our application engineers, solution architects, and myself. We can we'd be glad to come out to site to see you. On that size, I have done easily 1.5 kilometers. But I think it was a just slightly larger size that we did the 2.5 kilometers. Is there a certified installer in Canada? There are a bunch of installers of microtechnology in Canada. It kind of depends on what the market is. If it's an enterprise indoor fire-rated market, there are a few certified installers for that. There's one great large national installer that has guys across the country that can do the enterprise, and we'd be glad to guide you in that direction. And for outside plant, there's a vast amount of installers that install the microtechnology, and that's right coast to coast in both. Sometimes the installer of the duct is different than jetting the fiber, but there are multiple installers of that.
And Kevin, I think you see the questions coming in at the bottom of the screen now. So yeah. We do have one from someone saying a question regarding microfibers. Can you splice new microfibers to existing legacy fiber cables that are installed? Meaning if I had installed fiber years ago and decide to go with a MicroDuct system expansion, can we splice to this existing fiber?
So in a simple answer, yes. The glass itself is exactly the same. It's packaged differently. Now, in saying that, there is a transition on the fiber that we're transitioning to, so 250 micron single mode transitioning to 200, and then we've heard a newer 180 micron glass is available. So you can splice 250 micron to 200 micron. It's really, you're stripping the jacket off of that fiber strand, and you're still down to the 125 micron core of it that you would be putting into your splicer. Typically, splicing equipment can easily splice the 250 to the 200 micron glass if you're using that different glass. The difficulty comes within ribbonized fiber. So if you're having a ribbon 250 micron fiber to a ribbonized 200 micron, there are specific things that you need to do in order to splice them together. But yes, there's equipment that does that. Great question.
Any other questions? I know we're about 10 minutes past the end of the webinar, but want to make sure if anyone has any questions, we are here and happy to answer. If not, we want to thank you all for your time today and thank you for attending this CUIIC webinar. We encourage you to check out the Dura-Line Academy as well as the CUIIC page with all of their events coming up, their webinars, their innovation forum. There's a lot going on with this organization, and we thank you all for taking the time today. Hope you reach out to them.
Carroll. There's a little shout out. Thank you back. Thanks for attending. Thank you all. Appreciate your time.